Welcome to the Trend Detection Podcast, powered by Siemens.
I was on a call this morning, actually, and we found out that we'd accidentally given everyone full access to our Senseye knowledge platform. And usually that's something that we charge for. And in this case, it didn't happen. There's some form of clerical error, and everyone had access to it. And they loved it. They saw it. They got really enthusiastic about it. These are the maintainers, the people who are directly responsible for these, for this whole project, and they ran away with it. And they started integrating. They started putting in machines that we had no idea about, and they got it. And I think it was already very well aligned with their own internal processes and their curiosity. But it showed that we gave them the material, and it's not training on how to use Senseye Predictive Maintenance. It's material, workshops, training, reports, and processes around how you turn this into a successful business outcome. And when people could see, okay, now I can, by wielding my spanner in this way and in a more directed manner, now I can show directly that I am saving the company money and that I'm responsible for this and I've captured this win and I can communicate that effectively. Then people are really enthusiastic about showing that, okay, my job now has a much wider and more powerful meaning in the context of how we produce this product safely and consistently and at a certain cost point. Every customer wants some form of business outcome, but how they achieve that is different. What their particular KPIs and how they then translate that to a dollar, euro, pound, whatever value, that's slightly different and nuanced. And when we started, we used to think that everybody is exactly the same. We can take the same approach, talk about the same things like unplanned downtime. And you see a lot of people in the market now still talking only about unplanned downtime. And I think that's a rather poorly sophisticated approach. It's very unsophisticated. The fact is that with every deployment, we needed to sit down and understand from customers, how are they monitoring these KPIs? What matters to them? How do they then translate that to a business outcome? And that's why we developed the Senseye knowledge platform and the methodology around that, so that we had the tools to share with customers and to sit down together and say, what are we actually trying to achieve here? Because it's not an innovation project. We've proven that predictive maintenance works. We don't need to be innovating this concept. This is not a wild concept that no one has tried now. We have plenty of case studies about it. What we need to do is sit down and figure out how this is going to make your job easier and how that's going to matter to the overall business and how you can show that, so that we can establish that mapping from something weird happened on a machine to this is the business outcome. This is why we're doing it. This is why it matters. So first of all, machinery is quite tough, and you then need to monitor it and have some form of sophisticated understanding of where to go and fix and when to fix it at just the right time, so that you're not spending too much, because the margins in actually extracting minerals and things might be quite low. So you've got to do it at quite high volume, which means you need to keep doing things often through a number of shifts and through a large amount of machinery. And so downtime becomes very important. How can you avoid that unplanned downtime, particularly in areas where if you're processing and refining some form of ore and producing steel or aluminium, that's a continuous process, and you have something that is hot and effectively live going through your entire factory. If something fails during that point, you could waste all of that product, damage all of that machinery, and it might take you over a week to reheat that material and to reheat the furnaces and things, and the energy costs involved in that are phenomenal as well. So unplanned downtime through every part of that industry becomes really, really important. I think unplanned downtime, sustainability, safety, of course, is massively important, making sure that these things are done in a safe manner and making sure that they're not spending money where it doesn't need to be done. If you look at the efficiencies that we're able to make, and we go back to automotive, one of our first projects was to help a customer reduce unplanned downtime by 50%. And we did that. And that's a huge amount. But how did that actually affect their overall metrics, their overall equipment, overall operational effectiveness? It moved that figure by about 1%. And that 1% means millions and millions of pounds for that customer. But in order to see that kind of translation of a very small percentage point translating into millions, your production volume needs to be huge because your margins are so small. And food and beverage is actually quite similar in that way, where the margins are even smaller. The product is inherently very low value. So if you're looking at just a particular area in this plant, maybe we're looking at packaging, or maybe we're just looking at mixing. The argument to implement predictive maintenance on that is actually not very good. Mobile assets is really interesting, and that's been a challenge as well. A lot of these trucks, the size of a house or a decent-sized palace, they already have very sophisticated monitoring, but that monitoring's been really for a dashboard for the driver to say, hey, something's really, really bad, you need to stop. A much more sophisticated version of the check engine light that we all have in our cars. But now that we actually can have internet access, 5G, whatever, pretty much everywhere, you have the ability to stream that data out and to centralize the analysis of that. And that gets even more interesting. How can you start to monitor and optimize not just the vehicle, but the whole fleet, the whole usage of the fleet, and combine that understanding of how the fleet is behaving with how your crusher and how your grinders and how your conveyor systems are operating, and put that all together. That hasn't been possible before from a connectivity point of view and from a processing point of view, because Senseye Predictive Maintenance takes that very data-centric point of view. We can start to combine the data from these mobile assets with fixed assets. And people always ask us, well, you can do these conveyors and things, but can you do mobile assets? And really, it doesn't make any difference for us. We wouldn't be where we are if we didn't have solid use cases of companies actually saving money using Senseye Predictive Maintenance. And the fact is, we can leverage their existing investments, we can repurpose that without them really doing much at all, and give them so much more capability to improve their efficiency, to do it in a safe and sustainable manner, and to improve their bottom line in a really very measurable way. And the return on investment is typically 6 months or so. So it becomes a no-brainer. I think for one reason or another, there's quite a lot of crossover between oil and gas and the technologies and the approaches and mining and metals. And heavy industry is not just mining and metals for us. It's other things like concrete, pulp and paper and so on. But for us, we do see the most growth and the most adoption in mining and metals specifically. And that's because they actually have that whole culture of safety and appreciating that they don't want to be up against these machines all the time, that they need to be continuously running, and that they need to be monitoring. And that culture is really carried over from oil and gas. I don't know why. I've not really explored that too much, but it's something interesting to look further into. With predictive maintenance, you're then saving money by making sure that something doesn't happen. You are intervening, you're predicting that at some point something's going to happen. This is the right time now to pay attention to this. You're not having to get to the detail of, okay, in exactly 21 hours, this is going to happen in this way, blah, 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 blah. And a lot of people get too obsessed about those details. And the fact is, you have maintenance professionals who usually know what to do, but they need to know where to focus their attention. Mm-hmm. And that's what we're about. We're about making sure that people are spending their effort, spending their time in the right way. And yes, we can give remaining useful life predictions. We can give very detailed predictions about everything, but you need perfect data for it. When I say perfect data, I'm not exaggerating. It needs to be incredible. The only really good case studies for prognostics come out of things like NASA data sets, where it's perfectly manicured and beautiful to look at. And there's 5,000 PhD papers written about it already. It's not very good in the real world. So when someone talks about unplanned downtime and that's all they focus on, to me that means they just don't have much experience. They haven't actually done much of this, and they've experimented with putting some algorithms together and they've got some interesting results, and that's cool. The fact is, predictive maintenance, everybody can do it, and there are algorithms out there. There are things that you can get. You can bring in loads of data. You can see some cool stuff on 5 machines, 10 machines, maybe even 50 machines. But then to scale that out to a whole enterprise, the technology and the level of sophistication and experience you need is on a completely different level. And there aren't many companies in the world that can do that. And spoiler, we're one of them. So the traditional method is very good, very appropriate in some industries. The problem is, if you want to expand that to 500 machines, 5,000, 50,000 across an entire enterprise, you need to be doing a lot of manual human understanding of failure modes and building and maintaining models. That's incredibly expensive. So whatever money you save in the maintenance of something, you're going to be spending tenfold in the actual data analytics. Mm-hmm. And that's not a viable way to approach things. With Senseye Predictive Maintenance, we turn that approach on its head. We accept that the data that we're looking at is going to be poor. It's low context. It's noisy because that's what industrial data looks like. Things are never perfect as we want them. So we have to accept that. And that's one of our fundamental principles. Then we have to understand that the data we get is actually quite low context as well. So what I mean by that is we don't know everything that the machine is doing. We don't know everything that the company is producing, how they're doing it. We also don't want to know. Some of that's their IP. And to get them to share all of that, it's just not a really viable way of running our business. We want to focus on the machine. And then what the humans do about that. And so when people talk about predictive maintenance, they get all excited about machines and they focus on machines. We want to focus on what those machines mean to the business. And the business is about humans. So really what we're focusing on is the humans. We're using machine data to help that. Food and beverage does have its own issues, and you're often then dealing with perishable goods. So you need to make sure that when you're performing this run and it's all queued up, it's going to be reliable, it's going to work well, and that you're not spending too much on maintenance. That's probably one of the biggest areas that we see, maintenance efficiency. There's always this saying that over-maintenance is cheaper than failure, and it's absolutely true, but it's still really expensive. And we've had some cases where one site will be producing the same product as another, but spending 10 times the amount on maintenance. And yeah, they don't have any failures. But clearly, there's an opportunity to reduce their maintenance spend by 10 times. But how? And that's how Senseye Predictive Maintenance can help. We can allow people to say, okay, well, maybe I don't need to maintain this so much because there's not as much evidence, or there's no evidence that I need to go and do this as much as I need. There's no degradation seen on the machine. I can comfortably say that I'm not going to perform this planned maintenance. I can save the labor, save the spare parts, save the consumables in repairing that machine, and go and focus on something else that actually matters, that really needs it, and save that money. One of the really good things about the metals and mining industry is they centralized on, or they adopted the idea of collecting interesting and useful data quite some time ago. So they're decades ahead of some other industries. They almost ubiquitously use a data historian, which means that you get all kinds of interesting process data being collected because the process needs to be very tightly controlled, particularly when you're actually refining something and putting something out at the end. And that process data can actually be used for condition monitoring. And people don't think about it. When people think about condition monitoring, they think about vibration, going installing and retrofitting lots of things. And yeah, there are certainly some cases where the equipment you install needs to withstand very high temperatures, for example, in a pot room where you're melting these metals. But there's a different way to do it. You can start to use that process data that's maybe just looking purely at the timing of things and start to use that for condition monitoring purposes. Because if something is starting to degrade, those timing intervals are going to change. And that gives you that very early warning, essentially for free, that machine is not behaving quite in the way that you want it to. And that allows you to flag up, this is what deserves my attention, the other things don't. So we have some fantastic case studies with companies, and there's one in particular with a global aluminium company, and we managed to achieve a full ROI at a site within less than 6 months. We managed to enable them to reduce their maintenance spending by about 20% without installing any sensors. So they have no specific condition monitoring sensors. They weren't doing anything, but they were collecting process data that happened to be the right kinds of things: current, temperature, torque, timing. Things that are free from a process control point of view. They had already stored it. We really, I don't want to say we merely connected things and it just happened. There was still quite a lot of work to be done in terms of making sure we're looking at the right things. But they had that infrastructure in place already just as a result of them being able to do normal business operation. And they could repurpose that investment and infrastructure for predictive maintenance purposes. And that was awesome. As people interact with the application, as people go and perform work, we learn from that as well. What did they do? Why did they do it? That's recorded in a maintenance management system or within Senseye Predictive Maintenance itself. And we combine those two things. We combine this industrial machine data as well as this human data. And that helps us build context automatically by people just performing their normal roles. And it helps the algorithms become more and more effective, more and more efficient. And it helps people ultimately zero in on more and more what they need to be doing and relate that to a business outcome. So we're matching all of these things in the background and then learning from what people do about it. Think of it as almost like a music recommendation algorithm, but it's focused on machines. So battery production is interesting because there's an even higher level of automation. They're quite volatile chemicals. You don't want to be around them. There's fewer people on the shop floor than there are even in a mainstream automotive plant. And so battery plants are also seeing a massive investment at the moment. Every country is pouring money into this. Huge levels of automation, definitely a safety case there, business criticality case. And Senseye is perfectly well suited to monitor any and every kind of machine within these factories. Because of the way we designed the technology, we don't need to know specifically what this machine is. We need to know what the data is. And if the data is suitable condition monitoring data, then Senseye Predictive Maintenance will automatically create and maintain that model and work with that. So the beauty is that no matter what kind of battery technology is ultimately used or how things are produced or what kind of new innovations come in, we can work with that. We've always wanted to focus on machines in many different sectors and come at it from a point of view of not just downtime, but efficiency improvements, sustainability improvements, safety improvements. The less time that people spend near machines, the better. Sustainability is something that I talk about a lot, and everybody does now. And it's at the point where it's too much of a buzzword. But when we talk about sustainability, it's how can we use predictive maintenance to help organizations turn sustainability from a cost center into a cost saving. Everything that we're doing is ultimately about some form of business outcome that can be measured. It's all very well saying, yes, we can monitor this and we use AI and blah, blah, blah. What the business cares about is how can you improve these particular metrics that ultimately have a dollar or pound or euro value or whatever. So sustainability is a good one where people talk about it and they do a lot of hand-wavy energy savings. And of course, if machines run more efficiently, they use less energy. But that misses out the huge argument of you can also reduce your spare parts usage. You can reduce your inventory for that. You can reduce the amount of time that people are spending going to these machines and doing things about that. And the biggest argument, I think, is you can improve or lengthen the amount of time that these assets are going to be useful for. The problem with cost avoidance is you can't spend it. You'll get an accountant coming along saying, hey, there's 20 million that you've saved. That's fantastic. Can I spend it? No, because it's money that you never budgeted. Whereas a cost saving is, that's money that you had budgeted for labor or spare parts or some other form of service that you no longer need to do, and you can spend it on something else. So typically we start with, let's focus on downtime, let's focus on the easy metrics, and now that you're more advanced, now that you're collecting this, now that you understand what we're doing with predictive maintenance, we're going to use it to optimize things. Our currency of how we work is human attention, not machine health. And that flips this whole thing on its head. We're looking at machine data, we're working with machines, we're guiding people about where to pay attention with the machines, but actually what we care about is human attention. That's our currency. We take the data from machines and we direct human attention to where our algorithms believe it is most warranted. And then we learn from what the human does. Because our data is inherently actually quite poor, because we're looking at very simple condition indicators, things like current, torque, temperature, pressure, things that actually by themselves, they're not very interesting. But when you start to look at them over a length of time, and you start to combine them with other things, and you start to combine them with data sets that you feel are also similar, then you start to build quite an interesting picture. Then you start to build context that becomes more meaningful. And one of the best ways to build that context is by learning from what the humans do. They know this job already. Why sit them down in a room and get them to spill out everything when actually we can learn on the job?
Yeah,
I think one of the primary unique challenges is it's a dirty industry. And I mean that in every sense. So politically, environmentally, technologically, everything it has some bad connotations around it, and it'd be wrong of us not to address that elephant in the room. But the fact is that our technology can help that industry to be less dirty, to be more sustainable, to be more environmentally friendly. And so there's a huge amount of opportunities to do that. And the companies that operate in that area are actually very committed to making sure that they can operate sustainably and in an environmentally friendly way and in a way that's respectful to the earth and people. Because if they don't, they won't be in business because people care about that kind of thing now. And these companies are ultimately run by people. So that's one of the first challenges. How can they operate in a way that is respectful to people, the environment, and continue to do that. The large auto manufacturers are so optimized at mass producing a product in a really smart, integrated way, where some of the large factories are pumping out one vehicle every 30 seconds or so. That's phenomenal. And to do that, they have to be so optimized and so aware of the metrics that matter to their business. So downtime is one of those core factors. They're always aware of it. It may or may not be a problem in that particular area, though. And that's where we have to get into a discussion and say, look, is it actually a problem? Do we need to focus on something else? Or have you gone beyond purely looking at downtime and now you're wanting to look into cost savings? And that's a more advanced conversation.
Please like and subscribe on all major podcast channels and find out more about Senseye Predictive Maintenance at Siemens.com.